Good afternoon. Thank you, Marcus, for the initiative of carrying on these workshops after Ariadne and providing the forum for exchanging ideas, knowledge, and techniques. So this afternoon, myself and Denitsa are going to present the workflow that we have designed and use to try to do controlled representation of archaeological datasets. And so the presentation will break down in two parts. I'll start by giving the sort of frame of how we approach things. And then Denitsa will pick up from there and give a sort of mini theoretical example of how this actually applies. And then we're looking forward to the discussion and to questions and other ideas, etc. So just quickly to frame who we are, we have a company based in Plovdiv, Bulgaria, and we work on semantic data management consulting. We work with museums, universities, and projects, typically on cultural heritage and historical data sets. And we engage in helping in various stages of the process, which is why we are so interested in the overall workflow and how to join up all the pieces in the most efficient and reusable fashion. So if you want to find out anything more about us, there's a link here, and I think these slides will probably be presented later, so you can feel free to click over to that. So putting the large context on, when we get involved in doing semantic data projects, I think that the promise for most people is that we're going to end up with data that is self-describing, that is reusable, that is interconnected and could be interconnected with other data sets, and which could support rich semantic query and basically be an aid to our research and have the potential to create new research paths by making data sets that were previously siloed and incompatible, compatible or potentially compatible with each other, and allow us to ask bigger and different questions. So that's kind of the dream scenario. However, semantic data projects are subject to the same sorts of pitfalls that any data projects typically run into. So it often ends up being the case that whereas we had that dream, the projects end up being one-off activities, which are often affected by this syndrome of doing everything again all over again. So remaking the wheel, starting from the ground up, considering how to do all the modeling from scratch. So that's a big problem. Then as the project moves on, they tend to be under or undocumented, so the data is supposed to self-describe itself, but in practice, you need a lot of contextual information to actually reconstruct how your semantics are being used, and bespoke solutions come along. And so you end up, rather than being in the dream, being back in having siloed and difficult to reuse data. So what's going on with that? Basically, I mean, and we could certainly discuss this more, but I would say, a pivotal point is that formal ontologies like CIDOC, CRM give us a language to re-express data that's potentially reusable, interconnected, and sustainable. But actually, that's all they do, and that's not enough. So if we want to reach the semantic promised land, we need a whole host of tools and methods that implement best practice and can help guide our processes, document those processes, and lead us all in the same direction. So we need some sort of semantic data commons. So make that argument out of experience and out of trying to keep the projects that Takin.solutions is involved in going all in the same direction and not being bespoke and strange and difficult to handle. And in this diagram, I kind of try to summarize the overall position we take on the workflow for doing this controlled management. So at the very bottom, talk about a semantic project registry. So basically, this is foundational to just document the fact that you are doing a project, that you have these data sets, that they are stored here, that these people are responsible for them, that you are using this software, gathering all that contextual information, which actually allows you to recreate a project. That's helpful and useful in a number of ways, not least of which because semantic data projects tend to be ones that drag over time and people come and go and technology moves along. And so being able to understand who was doing with what software in what state and on which data set at what state is really fundamental. So that's something that we have as a sort of ground that we're trying to implement as a best practice to document the processes themselves. And then we basically break up the main processes of doing a semantic data project as ontological modeling. So if you have to do, if you have to create new classes and properties because you have new and interesting data that has something that's not covered by an existing formal ontology, this is where you would do that. And the question there is, how can you do that with a tool that allows it to be recorded and maintained? I'm just mentioning Ontomi as a tool that we use. It's open source and supported by a CNRS lab, LADA, in France. We're not going to talk about it today. Then typically speaking, for many projects, you don't have to do any ontological modeling at all. You need to do what we call conceptual modeling. So that is basically determining the field of things that you want to describe semantically and do an intellectual process of deciding what are the entities you talk about typically in that field, and then how can they be described with the existing ontology that is applicable to your area, and then design reusable semantic data patterns, which is going to be a big part of the substance of the demonstration today. So for that, you also need a tool. There are not very many tools around that we know of. We designed our own. It's called Zellij. We'll show a bit about that. And then that provides a having a well-documented set of conceptual data models, semantic reference data models, as we call them, is a great platform from which to be able to use other tools that are designed to allow you to consistently apply semantics. So there's a tool designed by ICS Forth and the Center for Cultural Informatics. I think Maria, who's a major player in that software, is here today. That is a software that really allows you to apply these consistent patterns, and one that we adopt because it allows you to do declarative mappings so that they can be sort of reread as intellectual objects between data managers, but also data users in order to control the ETL process. And then finally, some series of potential semantic data platforms, which should be open source and should allow you to apply documented and well-described semantic data patterns. So some of the principles behind what I've called the Takin solution here for the problem of creating sustainable and reusable semantic projects are that you should document, and meta-document everything you're doing as you go along the way, so that you can trace what's been done and where you got to, and what things you've used to generate and re-express data. A major distinction that we make internally is between conceptual modeling and ontological modeling, which I mentioned previously. So we talk about ontological modeling in the context of creating formal ontologies, And generally speaking, in research projects that fall within, or semantic data projects that fall within existing ontologies, you don't need to do that. You need to do conceptual modeling. You have to figure out how to apply the ontology, which is where things usually come off the rails and where we try to intervene with this idea of a semantic reference data model. So by not focusing on ontological modeling, you can focus your attention and efforts on conceptual modeling. It's usually mostly what you need, and reuse and reuse good software and good ideas and make your own stuff reusable, and adopt open source tools that have active friendly communities to support their advancement. So in the workshop, or in the practical component of this workshop, we're going to touch on two of the tools that we've added into the workflow that we think are important pieces in order to be able to do a controlled semantic data management process. One of them is called SemCMD, and it's for documenting semantic projects and all of their constellation of data sets and software and people that make them happen. And the other is a tool that we've designed called zellij, which allows you to document semantic data patterns or semantic data reference models. So a few words about those at the high level, and then I'll pass over to Denitsa to show how they can be put into use in practice. So SemCMD is a database for tracking semantic data projects. And if I were to give it a slogan, I'd say build a map of what you know and then integrate it. So oftentimes semantic data projects just jump straight into let's see what data we have and start coming up with ontologies and transformation files and build systems or what have you. But if you want to have a long-term sustainable and viable process where you're not going to end up with something that becomes obsolete and has no trace, then you need some sort of system to control what information you're trying to model, what data objects you've made to try to describe those semantically, and keep that up to date and use it as a resource for reusing things that are built well over time. So its aim is to support long-term data integration. It has been built out on the Arches platform, which allows you to implement born semantic data. It's based on a project that we had with the Max Planck Institute for the History of Science, where they wanted to build conceptual, semantic reference data models for controlling the data management process internally. So we built those data models, and then they've implemented it in the semantic software research space, and we've implemented it in this semantic software Arches. So that's a nifty application of our own work. We made some data models for tracking data, and then we implemented them using those models. And it's based on the Parthenos project ontology, which was part of a European-funded project for research infrastructures, and it's compatible, and the ontology was compatible with CIDOC CRM. There's a link there. Denitsa will show some example in that, but we are trying to use it ourselves to track our projects. We're in the partway through our documentation, so it's semi-incomplete, but everything's a work in progress. And last point on that, and Denitsa, I know you're taking your time, so I'm almost done. Arches allows you to release these things as packages, and so soon we'll packagize it and put it on GitHub, and so it'll be available to other people to implement it themselves if they so desire. And then a note about zellij. So zellij is really central to our work. It's a system for documenting semantic data patterns, and what we mean by semantic data patterns will be illustrated more closely by Denitsa. But basically, you have an ontology, but just because you have ontology doesn't mean that you have a strategy for how you're going to use it for some particular data, or how you're going to use it again consistently for the same problems over time. And so basically, zellij tries to help solve that problem by being a database of patterns that break down into fields, which are one unit of information that can be connected up into collections, which are a middle unit of information, and models, which are an entire recipe for documenting semantically a certain kind of real world thing. So that documentation, which allows you to build, is meant to be a blueprint for executing and reusing semantic data. It's supposed to be something where you document once and reuse many times. So the idea is to give these data patterns out to the world so that it can be reused and people don't have to think of them again, but can work on different or more complex problems. And we're in the process of adding a bunch of facilities onto it in building code around the patterns that allow you to take the pattern and then automatically generate a mapping file or a semantic data platform interface or the correct query for returning that data or doing quality control on that data. And the system is built on the Airtable database for now, and we have Python code which reads from the Airtable APIs and generates a public interface for interacting with the documentation and using it. All of which is being worked on for a new version, which will use other software, etc. But that's the MVP. So with that, I will stop this part and allow Denitsa to take control.
Thank you, George. Let me share my screen. Can you see my screen?
Yes.
Do you see the presentation? Because I have two screens, just to make sure which one are you looking at.
Yeah, we see the presentation.
Okay, great. Thank you, George, again for the nice introduction and presenting what we do and how we do it in theory. So I'll try to give like a very basic examples of different steps throughout our modeling, mapping, and documentation processes with a specific focus on archaeology. So case scenario, let's say I'm an archaeologist and I have an archaeological project. It's a standard excavation project that has data collected from the excavation and different analysis run on the finds and on site. So it has records about excavation units, about the stratigraphic layers and their relationship. It has artifacts, it has samples, it has the entire fairly standard data set of archaeological entities that are recorded. And I'm interested in turning this into a semantic data set. But I don't want to do this from scratch, first because I do not have the time, or just because I know that there's already some work being done on this, and I want to check what is compatible with my project and what is not. So I happen to know that I have worked on another project where we have developed an extensive data sets for semantic reference data patterns for archaeological data. And it has covered pretty much everything that archaeological excavations and beyond can wish to record and is currently storing in different file systems. Here it comes the SEM command that George presented. This is where we have documented the work that we have done on that project. And I'm gonna enter the search menu of the SEM command, and just by simply knowing what I'm looking for in terms of data set and its name, it's called the Common Ground project, which I'm not going to present now because it's not launched, but we do have the semantic reference data models that are developed by us. So if I go to the Common Ground semantic reference data models, and I see all the, click on the related resources here, I could see all the models that have been designed for this specific project that is based on various types of archaeological data sets. And here I could have an overview of the main entities that have been recorded and that have models developed based on them and are serving for recording such kind of archaeological data. So let's say I'm currently interested in the context model, which is also currently recorded as excavation units. It's compatible, they're compatible with each other. They're just based on two different systems. So let's say in my project is called excavation unit, but it refers to context model in the already mapped and modeled data set. And the other thing that I want to turn into semantic data set, it's artifacts, and the artifact is also here. So if I click on the report for context model, let's say I could see a reference to its digital access point, which is unfortunately currently not working as a link, but I could simply open it this way. And because we're still in development, it takes a little bit time to load, but I have already preloaded it here. So this is our zellij system, where you could see again all the relevant models for one project, again the same project that I have been referring to so far. So this is the menu with all the main semantic models. And in the current one, in context, you could see a basic description, and here you could start the display of all the fields that have been involved in developing the models. This is all type of data that needs to be recorded, from names, identifiers, and so on and so forth. The data is organized by categories, so one could easily find what they're looking for. You could have the simply the existence of a context as its substance. There are different ways to express relationships in between units, context and stratigraphic units, different people involved in all these events, as well as groups. You could record the time span and other different techniques that have been applied to the excavation process. It's very data specific, but also very general for standard archaeological data sets. So this is how I can view my context model and try to see first whether it applies to the new project that I want to turn into a semantic data set, or it's slightly different, or maybe I want to choose only certain patterns, or I want to slightly modify. But even if I want to modify anything, or I want to choose specific sections of the project, everything has names and classifications. So every context has a name and identifier. So this is one thing that we could start mapping using the existing data set, the existing semantic reference data model. And the other thing is artifact. Again, I'm selecting it from the left-hand side menu, and you can see it organized in absolutely the same way, but this time is human-made object specific, which is its main class. So one can zoom in and out of the individual graphs, but can also see underneath at the very bottom of the page for each project could see the ontology graph for the entire model and see how all the entities are represented and interconnected. All the semantic reference data models are also inter-referenced between each other. Everything is in a connected structure. We have also the option to see the instance specific graph here, which is much larger than the ontology graph, so it requires a lot of dragging and scrolling left and right. You could see the turtle itself for the model, and we have also a JSON LD option. So this is not only going to save me time in modeling my data set of the new project, but it also going to make data easily linked and sustainable on both sides, first on the documented project and then the new project that is potentially, if need be at some point, being connected to the existing archaeological data set of other projects. So once I have my documentation in front of me, I would like to start the mapping. And for this, we'll go to the friendly 3M tool, and it's XML mapping currently hosted on the Data for Science server. So I have prepared 2 mappings just for this exercise. I'm just going to develop them in front of you. But I have loaded their ontology, and I will tell you what I mean by that. I have them open here. So this is, so I need to do 2 mappings, one for context and one for artifact. So this is my context mapping. It has its name, and it has its target schema loaded, which is all the different CIDOC CRM extensions that I'm going to be using in the mapping. Currently, it's the main CRM, CRM Archeo, CRM PC, CIDOC, Geo, and CRM AAA. The other thing that we need to do for a successful achievement of an RDF in the end is the namespace prefix, which we have currently given it just a Takin example. And the next step that we need to do is to load the source records, and we need a generator policy file that will be our tool for creating unique identifiers for each record. So to do that, I'm going to edit this mapping, and I am going to upload not the artifact. First, I'm going to upload the unit XML, and I will show you what it looks like. These are just 3-4 fields that would display the name of the unit and a basic description, so we could get it going. And when it decides to load, of course, the server is a bit slow these days, so we shall see. Here it is. And if I display the XML, this is the tiny XML, but it's enough to display the structure that we're going to be working with. And we're also going to upload the generators file. And that one looks like this. It is specifically designed for archaeological URIs, so you could see artifacts and you could see context, and of course there are the standard place and digital object and other applicable URI generators that one may need. So we save these settings, and we could move on to the matching table, where of course having our documentation in hand, we need the CRM path. Whether we're going to look at it from the table or from the graph is entirely up to us. The most important thing is we have it and it's documented. So then we see that the main target entity is A2 stratigraphic volume unit, which is what we need to select from this side. And here we need to choose which is the main node in the XML that the stratigraphic volume unit applies to. And what do I mean by that is, if I show you, so we're going to need to display all these fields here, let's go. So we need whatever is the umbrella above. So we need the unit node in the XML. Once we have selected this, we could start the mapping of identifiers. So we could click on add new link, and we could go to our documentation again. So we need this identified by linguistic appellation. It's our first identifier. So we go for P1. And because we actually need to display the value of it, we need to add an intermediate, which will allow you continue after the E33, E41 with another expression, another property, which is the symbolic content. And then we're going to add the string. And here now we can actually point to the ID from the XML, which is this part right here. And we could save this and then add the next one. I'm just going to do 3 of this. The next one is also, and just to save some time, I'm going to delete what I just started, and I'm going to copy the previous one and paste it, because the next field has exactly the same semantics. It just has a different type. So I'm going to, instead of mapping ID here, I'm going to map name. And to both of them, I'm going to give constant expression. So to this one, I'm just going to add not P2 and wait for the type to appear as type. And here I'm going to write excavation units name. And to the upper one, I'm going to create the same P2 E55. But I will give it the excavation unit number. And this is what's going to differentiate these two nodes. And besides that, I'm going to give the description field, which is going to be 67. According to, of course, that means that I am checking my documentation here, but I happen to know it. So it's going to be the 67I-E33 linguistic objects. And that also needs to have its symbolic content in this very basic mapping, so that we have the contents of that field displayed as a string. And we're also going to give a type to this one, because we may have more descriptions than this. And we also need some sort of a label for it, which will be the field name, the current field name from the existing database. And that will be excavation units comments. And here, of course, we need to point at the field that contains those comments. And now it seems that we have done the mapping, but we have not yet, because the most important thing is the generators, which is going to allow us to actually display the data. And here we have already selected the context URI, pointing at the path that will give us the ID of the context. And then we need to work a little bit more on the other generators. So for identifier, we're going to choose not the direct URI, but we need an appellation identifier for this, which we have previously created. We need to display it right from this field. And also, the appellation itself, and we need to give it a label, which in this case will be just a simple label because it's the value of its own. And we need to add a type generator for the types that we have just created. And those will be, instead of expats, we'll give them constants. And this is our excavation units number. And we'll add it a label with the same constants. This time we'll just make it a literal. And I keep making a typo here, which does not really matter. The language will be English. And we need to repeat this for the name and for the comments. Bear with me. I will make it so that I can successfully have an RDF in the end. Otherwise, if I don't have all the generators, it will fail. So I need, again, a context appellation short URI. And that will be pointing to the ID field above, not to the one that we're currently working with. But the appellation itself will come from here. And we'll add the type. Type URI. Constant, and this time is excavation units. Unit name. And so will be its label. Sometimes you need to keep clicking on the previous change that you have made so that you could see it displayed. And for this one, we give a simple label. And that will be the text itself of this label. And there is one more generator that we need to do for the comments fields. And for that, instead of appellation, we're going to use so-called statements URI. Because it's a long string, something similar to description. So we're going to shorten it so it can be used as an URI itself. And again, we have to point to the ID of the context itself. And here we're going to do the statements. Give it a type. And instead of just simply typing here excavation unit comments, if we find those fields in a controlled vocabulary, we could type the URI there and use that instead. A common thing is AAT from the Getty. Currently, though, for the sake of the exercise, we're just going to use this. Constant English, and this is the last label that we need to add, which is the context statement label, and that will refer to something more friendly to read, which will be the name of the context itself rather than just the ID of it. And now that we have all the generators done, this is the actual content, so it doesn't need any more work. We go to transformations and we run the transformation, and we have done everything correct. We shouldn't get any errors here. And it seems like it's the case. And now here we need to find our main node, which is the stratigraphic volume unit. And we need to copy it from here, save the target record, and then we could visualize it to see what we have mapped so far. So we have our excavation unit with its name. It's identified by its name. We got the type as we planned, and we could see the URI created here with the Takin example namespace. And we have also the excavation unit number as another identification. And we also have a statement about the excavation unit, which is the one that we just created. Now it's called comments, and it has this content. So this is the way to continue with the mappings. I wanted to do also artifact, but because it's a slow and annoying process, maybe we should skip it. I can just show you how to run the transformation over this. And another thing is, for example, here, we saw that there is an information about a trench from the export that I have done. But currently in the modeling, we do not have anything that refers to a trench. Well, actually, that was for the artifacts. So I need to do the artifacts, or do I? Anyway, sorry. This is conversation between me and me. Anyway, let me do the transformations and we can see how are we doing with the time. Right, so to do the transformations, the actual XML transformation to an RDF, we need to export the mapping. So this is my mapping 1215. I will go back to the server and I will export the XML by just simply copying the XML. Sorry, not copying the XML. By exporting to XML. And this will save it in a folder with the mapping name. I'm going to unzip it because I'll need to access the contents inside. And also I need to put in that folder this jar file, which is the actual transformation engine. And I will do something else, which will be to rename some of the files so that they're easier to edit in the command. So I'll call everything that I'll need mapping 1215. This is the XML file, the source XML, which is this one, and the generators, I will just simply call generators as opposed to everything else that comes before and after. And now that I have done that, I can go to my terminal and don't know if you see everything till the bottom. I'm gonna bring it back here. So I've been working on another mapping. I will exit this and I'll cd to my mapping 1215. And now that I'm here, I will execute this command with, let's call, yes, sure. So this will be the output.rdf. We could call it whatever will be meaningful for you. The important thing is to name the XML and the XML with the names that we just label them. Mapping 1215. Is the XML, and this is also the XML map in 1215. And we run this, and it gave me a error for some reason. Mapping 1215.xml does not exist. It has 2 dots for some reason. I get a strange error. Generators.
Your generators file called generators.xml.
Yeah, it is. Oh, typo. 2R for some reason. Yep, there we go. So this is prefix. It's not an important error, but now we have actually created the RDF, and if we click on it, this is the results with all the data that we have exported from the existing excavation database, mapped it based on the existing modeling, and this is the outcome out of it. And because we're running out of time, I'm not going to show you how to with an example, but I'm just gonna explain that don't need to follow specifically the developed patterns and the models as they are in the developed version that you may or may not use and reuse. You can also divert from it. You could reuse only the parts that refer to you, and you can add new fields and expand the models and different branches as you see fit. In order to do that, specifically for us, and with the use of the zellij software, our backend is Airtable, which is where we have the models first developed and documented. This is simply the backend replica, let's say, or the platform of what you see here, grouped in the same way based on the same grouping factor. And there's a second base here, which is the fields, which is invoked into this model base in the field called field, but because it's syncing from multiple bases, it needs to have its own structure here. So within the field base, you could always go and type a new identifier number and just simply develop the ontology needed for further outbranching the patterns that you're using for your modeling. And once you have done that, you can, so the field base is the one that contains the fields. You sync your model base with the field base, and the end result immediately shows up in your zellij documentation outcome. I think that was it as the demonstration. We're open for questions, comments, anything else. I believe I have to leave at 4:15 sharp, but George might be available for a few more minutes afterwards.
Yeah, and maybe to just put a point on it in the end.
This one.
Yeah, this will distribute around, so you can take a look at the all the things we've mentioned and explore them. But I just wanted to highlight, like, this is not the way that many semantic projects work. Usually the idea is go to formal ontology website, download the standard, spend months reading it, figure out how it goes, and then try to apply it in a weird and wacky way that isn't the same way as everybody else. And so the main difference in strategy here is that either, if you are very good at semantic modeling, then you do your semantic modeling and you document it and you share it to others to reuse, or if that's not the focus of the work, but the focus is to try to integrate with other projects or to try to adopt good modeling that already exists, to not start from the beginning, but to go and borrow good modeling and then have a set of instructions which you can use to use a tool like 3M, for example, which is incredibly powerful. But there's so many complicated pieces of the puzzle, understanding the ontology, understanding the tool, et cetera, that taking down the cognitive friction as much as possible and making available patterns that are already well tested is a way to make it easier to action semantic data, and then B, if one of your goals is actual integration and not just theoretical integration, then having a common semantic set of semantic reference data models gives everybody the marching orders of how to get there. And then you can obviously use whatever tools you want. So maybe some people say, I don't want to use 3M, I want to use Karma, or I want to write my own Python code from scratch. Also great, but you still have a roadmap of where to go to. And yes, and then, yeah, last point on that. And so like there are these large, international or institutional projects like LinkedArt, for example, where, people are trying to make agreement for a set or a context of data, how they will apply an ontology like CIDOC CRM, and then everybody try to work in that same direction. So we're in the same spirit of that, of saying, let's follow established patterns, and then when we find new things, for example, we're working in this archaeological context, let's write them up and then share them with others, and then they can be reused.